checking that out. Good morning, everyone. Good morning, everyone. Just settling down on the YouTube stream, just checking that out. Second, why? Okay, we are all set. Today we are going to start, and we are now going to move little bit more ahead in technology. And today we are going to cover uh, notebooks and notebooks with PySpark. So we already seen Spark SQL, and I'm hopeful that you guys have practiced Spark SQL and as well as TSQL, and you would have find there are a lot of similarities. Uh, Usually, whenever we are going to code on the notebooks, we are going to prefer one of the language which we are plan to use. We can combine in different shells like Spark shells like PySpark, Spark SQL, and all those. But usual preference is that once we start with a particular language, then we would like to continue with that. So today we will learn the basic PySQL command which you would be needing for data manipulation, like how do we join, how do we filter, all those things we can go ahead and try that out on the PySpark. So to start today's journey, again we have to go to the workspaces. So on the left hand side of your app.powerbi.com, hopefully everybody has opened that, you will find workspaces. There's icon in the middle. And once you click on the workspaces, you can choose the workspace where you are working. So today is the English class, so I'm going to use the Amit-workspace 01. So I'll click on that. This is what I'm using for this particular class. Now the workspace is open. Now there are two ways to reach the notebook. One way is I click directly on the new item notebook, or I go to a lakehouse and do it. Now we have tried out both of them in the past. We can adopt any one of these. Only advantage opening it from the lakehouse is that I don't have to explicitly attach my lakehouse. But let's look at the way we using the new items. The new item on the top of your workspace, left hand side, below your workspace name. Then click on new item. You should make sure that all the items are visible unless it is marked as favorite. Now search for notebook, and you will get notebook option under get data, prepare data, as well as train data. So ideally today we are preparing the data, but you can click it any place. It doesn't going to make any difference. Not going to make any difference. So we are going to click anywhere. And now today we are going to learn PySpark commands. So we can rename this notebook once it is open. Once it is open, then you can click on the name of the notebook and you can call it PySpark command. Okay, and those who've joined a little late, I'm going to give the Medium link again. This is the Medium link. If you scroll a little down, you should be able to see the instructions which we are trying out today. At the end of class, I'll also share the set of instructions in HTML format so that you can also use that. Passing the same on the YouTube. Now to begin this journey, right now there is no lake house or warehouse attached. Now, as you know, we can use both lake house and warehouse. Now for the warehouse, PySpark is recently being supported. I will give you a video where you can watch. Not everything is supported. It's just the beginning of the PySpark for warehouse. Again, it's not a single step process. It's not native to warehouse. So you will see that, the PySpark commands there. If you look into the details, work in two step, not in a single step. So that article also you can read from Microsoft when they enabled it. But here we are going to use a lakehouse by clicking on add data item, and lakehouse Spark is kind of native. So we should be able to perform all those operations easily. Now add data item, existing data source. We want to use the existing data source, existing lakehouse. Click on that and we can use lake 01. Now I have two lake 01. Also, if you have access to multiple, like some of the people has given me access, I can see their workspaces, but I'm going to use the one which I'm using for this particular class, lake 01, and I am going to click on connect. So click on the connect. Now this will attach the lake house. Now there are chances that you can attach multiple lake houses. One of them would be default. So if you see here on the right click of this, set as default lake house is disabled. The reason for that is when you click, when you select only one, that is the default lake house. But when you have more than one, you will have more than one default lake, more than one, then you can choose one default lake house. Now the default lake house means the table names which you are going to give, they will be using the default lake house. Like if you simply say dbo dot something, which lake house it belongs to when you have more than one lake house? It's going to belong to default lake house. So default lake house is going to work unless we specify the complete name. What is the advantage of having this two lake houses here? Assume that you are using medallion architecture. Now for medallion architecture, the best way to implement would be bronze, a lake house, silver, a lake house, and gold, a lake house. Three different lake houses. You will say we have schemas. Why don't we create schema within the same lake house? That's also possible. But then we can use schemas for work areas like sales, finance, master data, marketing, or master data could be in separate workspace along with own lake houses. So my suggestion would be implement lake houses, each for one layer, bronze, silver, and gold. And then here, now you are going to do operations when you are going to do your first set of transformation, cleaning transformation. What you are going to do? You are going to clean the bronze data and move it to silver. So then you need the complete name of the lake house. So if you go here and let's say if you are working with two lake houses, then let's drag this here. See, lakehouse01 dot dbo dot dimension city. Now here we are not writing down the workspace name, but if you have created a lake house with schemas, then ideally you should be able to use lakehouse name, workspace name, dot lakehouse name, dot schema name, dot table name. It is only possible to have this name when you have used schemas. If you have not schemas, lakehouse name, dot schema name, dot table name. So I'm trying that out. This single quote is the different one, which is it is near to the one, the tilde sign. The So it's that one. It is not your normal single quote, which I put down. Let it run. Now I can give you this command. You have to change the table name here. Please remember, if you want to run this, you have to change the table name. Or best is drag and drop one of your table inside this one. So you can do drag and drop inside one of the empty cells. If you do that, you will be able to see the data. Now, once you're, while you can try out, let me explain what is this. DF is data frames. Now, look at an important thing. In this notebook, and we have explained notebook a little bit in the past, I just dragged it. It automatically created spark.sql from where the spark came in. So the moment notebook starts, it automatically creates the spark code. Now you don't need to create the spark or like, if you typically work in Databricks, or if you typically works in the notebooks, when you work with Spark, you have to create a Spark instance. That you don't have to do. You have to default your location. That you don't have to do. Here it is automatically doing it. After that, so you got the Spark, because once you run the Spark engine, you need one variable which contains the Spark. From there, you can run everything else. Now to run, I need spark.sql is the function. Inside that, I can write down Spark SQL. So this is my Spark SQL. Select start from workspace name dot lake name dot dbo dot schema name dot table name, and here limit 1000 works. Here we are not saying top n. Then display is the typical Python command. Pandas also it is available. Display df, display Spark data frame, display list, display Pandas data frame, display most of the thing you can do. Now display, if it is a data frame, it gives you a table like view like this. Okay. Now once you create a data frame is kind of table. You can understand it's a table, in-memory table available for you. So once you get this kind of in-memory table, you can now use the data wrangler. If you see option here and here. How did I run the code? I clicked here and the code started running. This we have seen in the past. Now very first time it does start a Spark session. After that, the Spark session will continue. If you stop for a longer time, it may time out and stop. Otherwise, for our session, it will keep on running. It will continue to use. So try out your first command. In the PySpark, we are creating here a data frame, which is using the Spark session variable. Spark is a Spark session variable here. In the Spark session variable, we are using .sql to run the SQL. Inside double quotes, we are giving the complete command, and then we are displaying it using the display function, which gives us a tabular look. Try this out and start sharing screenshot. Your table name could be little different. Your workspace name could be little different. It should not be same as mine. Okay, so those who are trying out by watching the video or trying out, make sure you drag your own table. The same table name might not work. The same workspace name might not work. Now we know that I can get the data inside the memory of Spark. I want to experiment a little more. So I went scroll down below my last output. I hover over. When I hover, I'll see the code button plus code. Now I would like to experiment more. How do I bring in my own data? Now to bring in my own data, I'm going to take help from Pandas. Pandas is a library which allows you to do a lot of analytical operations on Spark or on Python. Python you can do, and then Pandas data frame can be converted into Spark data frames. So Pandas data frame, the DF of the Pandas is going to be little different from the DF of Spark. Pandas data frame directly cannot be saved in Delta format file. You can save that as CSV, but Delta it cannot be saved. For that, we need Spark data frames. So we will see at one stage we are going to convert these Pandas data frame into Spark data frames also. So while both are data frames, Spark data frames are little different. So anytime we want to use an additional library, that library should be available first of all inside our ecosystem. So if it is not installed, then we use pip install. Usually the default libraries like Pandas are available with us. So we do this import Pandas as PD. So what I'm importing Pandas library, and I'm giving it as an alias also as PD. So import Pandas as PD. This is the first thing you are going to do. And those who have taken the Medium link, all these instructions are also given on Medium. Okay. Then the second thing is I need Excel path. This is the same GitHub path if you see. So https github.com Amit Chandak PBI Power BI raw main sales data for fabric, and percentage means there was a space, percentage 20 I think space or underscore, it gives you that. So this is the path. you can use that. All of you can use that. Now I'm reading a Excel file from generic path. So what's the function for that? So I'm now, this is just a variable having the file name. I'm not reading it yet. Now to read, I'm going to use pandas. PD dot function is read Excel, and inside that Excel file path, then I have multiple sheets. So I'm giving the sheet name. And what this is going to do, give me after reading the Excel, the data, where will I get the data? I'll get the data into data frame, pandas data frame. So df.sales is the pandas data frame where I'm going to get it. So I'm reading the Excel using pd.read Excel file path, and sheet name is sales, and I'm reading it inside the pandas data frame. This is the complete action. The same thing I'm doing for customer, geography, and item. So all four of them I'm loading. So till now what we were doing is we were using pipelines, we were using Dataflow Gen 2. Now today we are using Pandas library, Python notebooks, or you can say PySpark notebook here, because Python notebooks are also available. They doesn't start the uh, PySpark engine. So let's say if there is something which I can do using Python, I can do that also using Python. I don't need PySpark for that. And that is why you have the Python notebooks also. So if you look here on the top, you do have Python notebooks, T-SQL notebooks. They don't use Spark engine. They use their own engine. So here when you run it, you will also see, like here you are seeing standard session, and that session you can see the definition of that session here. What 1 to 0 nodes, compute, medium, and all those. Similarly, when you run on the bottom, I think in case of Python, it displays what kind of machine it is using to run that. How much compute power you are actually consuming, because you are bothered about compute power. Every operation you do is consuming some of your compute units. So now what we are going to do is we are going to run all these. So I'm going to give you that. Please check. I have already given you 2 instructions before this, and you can follow the Medium blog. I have given link just above. All the instructions are given there. Just go ahead and run this. So it will create 4 data frames. See, just in 13 seconds, it has quickly created 4 data frames. So you can understand the power of Python and PySpark. So here it is just Python because we are using Pandas, but definitely the Spark engine is running right now. Now we got these thing. Now one other thing is we can start experimenting with that. So I definitely need to know the data which is inside, isn't it? How can I experiment without seeing the data? I have multiple ways to see the data inside these data frames. So one of them you already seen, display, but we also have function known as print. And in the olden days, we used to use this print function. Now in the print, we can use dot head to cut down the head. So simply we displayed the df dot says default head is 5, and then I'm printing that. So in this manner, you can print your data frame. So try out print df says dot head. You're printing just some sample rows to check out how my data looks like. Let me paste this and explain you a little more about this. So df is your pandas data frame in this case, df sales, and you are simply using dot head, going to give you sample rows from the top, and you are using the print function. Inside that, you are simply giving a data frame, a cut down version of this data frame using the head, and it's going to print that out. Similarly, you can print other things and check it out. Do you have any question? Anyone having any question? Please unmute and ask. or you can type in the chat window. Same is true for YouTube. If you have questions, please type in the chat window. Scroll up and do follow the Medium blog for the instructions. Now we know. So we already seen display. That was the Spark data frame, isn't it? This was Spark data frame. Can I use the same display function to display the Pandas data frame? So let's try that out. Display df underscore sales. Yes. Yes, we can use this. We can also use Pandas data frame inside display. What does it give? A table. Now in this table you can filter. Let's say you filter 230. Anywhere in any of the column 230 is there, it's going to filter. 23, any column it has 23 is going to filter. Whether in the date, like it contains 23 in this date, it is filtering. It contains 23 in some, like in item ID here, it's filtered. It contains 23 in the city item, it's filtered. Somewhere it might be containing 23 here also. Okay. So any place it contains 23, it just filter that out. So one function is there. Then you can create a new chart here. Can you see this option, new chart? You want to analyze this data? You can click on new chart and it automatically created it on one of the column, like count of order number. Fine. Then you can, what you can do is start editing, scroll down, start editing. Then you can have title, bar chart, subtitle. What is the x-axis? X-axis is order number, y-axis is also order number. So what we can do is x-axis, let's say, is item ID. Y-axis is order number, we can say quantity. So we have item ID, quantity, and we can uncheck the order number if you want. I uncheck the order number. Now it might be coming as count. I can use the aggregation as sum. So sum of quantity, show the legends, show the legends, position is right, series or groups. Okay, if you let's say wanted to have one more cut of the data, you can use series or group. Do you want to see stacked visual? Do you want to aggregate all these things you can do. And further there are advanced properties also, theme, label, scale. Pretty much if you want to do analysis, you can create this visual and experiment out with this. So just go ahead and experiment out this visual, create different kind of visuals. Like this is bar visual, you can go and create a pie visual also. So just go and do little bit of experiment out here. And start sharing the screenshots with the pie visual. Let me see, have I given you display function? So let us see. Okay, I have not given you. So display DF sales. Hopefully you have created DF sales already. If not, check out the Medium block. Quickly go ahead and create it. You might not found the display DF there. I have separately trained it. I first there converted it into Pandas Spark data frames, and then I have done that. But here you can do it, and you can have multiple charts also. You should not be able to start the trial, but I think on the very first class, I shown you that when you create the workspace, you should be able to use the existing workspace. You should be able to use the existing trials. There are 5 trials. Now, when you start the trial, you should be able to go to pro, not to. You should able to get a pro license or PPU license, and you should be able to create a workspace. And in that workspace, you should be able to use the capacity. One of the capacity, 5 capacities are there. One of the capacities you should be able to use, and that should work out. I think we explained that in the first class. And if you are just check that out, that you create a new workspace and in that choose the capacity. Now, some of you might get an error because you did not get upgraded to pro license. Then check out, do you have an option for that? If both the option does not work out, I can create a workspace and give it to you. Notebook not support Pandas SAI library. How, hopefully you are giving import pandas as PD, this one, isn't it? You have given these. Make sure you have given this. Pandas is PD. If it is not, then we have to go here and use this one. Pip install pandas. Right. Ideally, pandas is, I think, inbuilt. I really doubt unless you are not importing it. And once you import and run, then it's available for all the sessions below. So make sure that you have written this one and executed this one also. Now, in the next one, when I'm using pandas, I don't need to, let's say, if I run anything else, I don't need to go ahead and again import pandas as long as it's the same session. Once the session stop, then I need to again go back and import pandas. Then I start the new session. But otherwise, I can continue. Anyone else facing any issue? Now, those who have logins, again, make sure that you start a workspaces, you created a workspace. If in that workspace, choose a capacity. If you are unable to create a workspace, make sure you able to start a trial for pro or preview trial. And even both the things do not work, then you come back and tell me, I'll create a workspace and I'll assign a capacity to you, and then I'll give it to you. Then you should be able to use that workspace. Now, next thing which I wanted to do now, this is a little different from what I've shown you in the blog. I just want to see what is this data wrangler. So, and this data wrangler, I was also able to see here, data wrangler. So what is this data wrangler? So I have these many data frames. DF, the first one we created, DF sales, DF item, DF geo, DF customer. So let me click on DF sales. Now, when you look at this UI, what you will find out that this is very similar to the UI which you have seen in the past, where you have seen the data in PySpark. So you have seen this similar kind of UI in Power Query or Dataflow Gen 2. Now here you see order number, missing, distinct, all those things, little different. It's not PySpark exactly. So those kind of things. Now you have the views, you have save as CSV, add code to notebook. Right now, why it is not coming? Because we have not done anything here. Now, if you look at the operations which you can do, see, find and replace, drop duplicate rows. You have tried that out in Dataflow Gen 2, drop missing values, fill missing values, fill and replace. We have tried fill and replace, format, capitalize first character, convert to text. Very good. We have all these formulas, multi-label, one hot encoder, calculate length, create column from formula. Okay. Then we have numeric, round and all those. We have schemas. We have sort and filter. So let's say, can we filter? So what we can filter? We can filter, let's say item ID 1, 2, 3, 4, something like that. Let's see how do we filter. So filter, target column is what? City ID or customer ID? Let's take city ID. Containing string or equal to 1. So now we got this code. See, how do we filter? df dot df says, inside df says, we have given df says equals to 1. It generated a code. Okay. If you want, you can apply this. So now this got applied. I want to do more operations. So now my data is restricted to city ID 1. Same way, I can go and split text. I can use multiple, all these operations. So you can try out all these operations. Some of those you are going to try manually. Now let's say I want this code back, what I've done. So what I can do is add code to the notebook, and I come back. I come out of that, and you will see here I have df clean data, df says equal to df says city ID equals to 1, returns df says clean equals to clean data, df says dot copy, display df clean says. I'm not going to execute this because this is going to reduce my df says data. But just to check out, it is not already executed. Let me go ahead and see here that I'm getting data other than city ID 1. Right now I'm getting, but if I execute this, I this df sales is also getting modified inside this procedure, but outside this procedure I'm going to get it inside the df sales. So what is this? This is a procedure which has been created here, a function define a function clean data which we're going to take df sales. So it is not my variable, it's a local variable df sales. Df sales is getting filtered. Df sales equal to df sales ctid equal to 1. So df sales is this and return df sales. So now this df sales is not same as my df sales because it's a local variable. And then it's going to return this inside here. So df says clean, I'm creating a new data frame equals to clean data function which I created above. I'm calling supplying df sales dot copy, a copy of df sales, not even the original df sales, and it is returning me df sales clean. So in this manner I will have both my df sales and df sales clean. In this manner I can do it. So now you can, if you don't know the command how to perform it inside the PySpark, you have data wrangler where you can go ahead and try those operations out, and using those operations you will be able to learn those commands. How do you do it? There could always be better ways. Python is a language, and as you understand any programming language, you have multiple options to do the same thing. You might have a better option or better code available, so you can go ahead and find out those. You can take help from ChatGPT to find out like what is the alternate for this or what is the better option for this. We'll move forward plus code button, and now what I'm going to do is I would like to do few more operations, but before I do that those operations, I would like to convert all these pandas data frame into Spark data frames. How do we convert pandas data frame into Spark data frame? So in Spark we have functions spark.create data frame, and we have arguments like data, schema, sample ratio, etc. So here actually I'm giving another data frame which is pandas data frame. So df sales will spark.create data frame df sales, and it will convert it into a Spark data frame which is sales. So sales, customer, geography, and items are going to be the Spark data frames which I'm going to use here. So let me run this. No need of selection. I'm just selecting it so that I can paste it for you. So now all of them will become Spark data frames. And the advantage with Spark data frame is that I'll be able to save these things in delta format. So if I want to save these into my lake house in delta format, I can do that easily with Spark data frames. It is little challenging if I only want to use Python. Spark makes it easy. Now again, you guys can try df display, but I know we know that we understand that command. We don't need to again learn it. So I'll skip the display functions which are shown in the blog. Now what we want to learn is describe. What does describe do? Let's understand that. So sales.describe and show. First describe this table. So what is going to do is going to give me stat about each of these columns. Okay, count, mean, etc. So we are going to get the stats. Small number of stats are going to come, few stats about each one of them. You can run one of them or you can run all four of them. They will come one after another one. So sales.describe is going to give you stats and show is going to show that. Okay, so show is another command to display the things. So let's try this out. And once, let me give it to you. You guys also try it out and then I'll explain it to you. All of you can try this out. And see, some operations are common between both the data frames. So some of you might directly try it on the pandas data frame and it may work. It doesn't mean that everything which I'm doing is not going to work on pandas data frame, or some of these things will work with little difference. So Spark and pandas data frames, there are common operations which can work in similar manner. And because they are little two different entities, there could be very small difference in some of the things. So if you are trying it on different one, be sure that things may work or things may work little differently. So what all we got here is, so we got see summary. What we got in that summary is basically count, order number 30,000, mean 15,000, min 1, max 30,000. So I think this is little heavy table, but if I go to the city table, you can better understand. Is only few columns: city ID, city and state. So count is 100, mean is 50. Dot ID we have 1 to 100, so mean is definitely going to be around 50 only. Standard deviation also, it doesn't matter much here. Now standard deviation will not come for text column. Mean will also not come for standard column. Minimum can come, okay, and max can come. But all these matter more for columns like quantity, okay, and sales and gross sales and etc. So you want these stats when like that. And if you want to better analyze, maybe you can use display on top of this. So let's try. Can I use display instead of show? So scroll down, code, display, describe, and now you can scroll and see. I have 30,000 count, means all the quantities are available. Mean is 1.666, standard deviation and 0.166. Minimum is 1, max is 3. So I only have 1 quantity, 2 quantity and 3 quantity. Only 3 values are there. Look at price. We have but much bigger variation, 40 to 1733. And also you can look at big standard deviation, and average mean is also towards 200. Basically, it's more towards the lower value. Okay, same way cost you can also see. Discount percentage also you can see this 23.03. If you would have analyzed this data on Power BI also, you would have get almost similar average, simple average of discount percentage. And we have maximum discount percentage as 45. And you can see this mean is almost lying in the middle, while others are, not. For others, the case is not like that. And the reason for that is this is generated data. So when we generated the discount percentage using the random function, it almost generated near the values, which is very near to the average again. This plus this is almost 23 divided by 2. That's why these values are there. Okay. So now we have analyzed using the describe function. Describe function provides us some statistical numbers, and we can use that. But we have one more function, one more statistical function, which is summary, which can also provide us more details about the data. So we will now try out summary function. Again, use any data frame you have. On that data frame dot summary and display it. So display geography dot summary or display sales dot summary. Whatever you want to try, just try this out. A summary, you're going to give you more stats. It gives you count, mean, standard deviation, min. This you were getting already previously. Where are my 25% value, 75% value, 50% value, and 75% value? This may make more sense when I do it for sales table. So instead of geography, you can use sales dot summary. So we are now using the statistical function sales dot summary. And here now you can see where are my 4 quadrant, 25% quadrant, 50% quadrant, and 35% quadrant. So in my 25% quadrant, what are the things I have? The 67, 91 for the quantity, and then 133 is reaching by 75%, and by max I'm already reaching by 1733. All these stats also you can get. You can get more details about this function and what all information you give either on the blog, or you can also read out, what's the summary functions give me over the internet. So these are the things which you can try out. Now we will move to little bit of more of data analytics journey. I would like to filter the data frames. I would like to do more operations there so that I can go ahead and learn how to do left join, right join, inner join, etc. for that, what I'm going to do here is, let me do one thing. So I'm going to filter my data and I'm going to create two data frames where I'll be able to do these operations on the sales and customer. But right now, my sales and customers have the complete data. So I cannot simply run all the joins. Now to run all the joins on this data, what I can do is I can reduce the data in these two. If I reduce the data, I will make sure both the tables does not contain some data so that I can learn all the joins and then I can go ahead and understand dot join. So what I'm going to use, I'm going to create two more data frames, sales filter and customer filter. Sales filter, sales data frame dot filter function. This is another way to filter. And there I'm going to use sales data frame dot customer dot between 59 to 62. Now there are different ways to use this filter for number value between equal to all those, or you can have a clause also, just like we have tried above. So you can have a value based clause also. Similarly for customer, I'm also doing customer dot filter. In the filter, I'm passing customer dot customer ID dot between 50 to 60. So those two data frames I'm going to create the filter data frame. Let me run this, and let me also share this command with you. So now I am filtering. So if you remember in SQL, we were using where clause, where customer ID between 59 to 62. Here I am not running the where command. I am running dot filter function, and using that dot filter function, I am able to get the data in two more data frames, which does not contain the complete matching data. Now I'm all set to analyze these two data frames, the deficient data frames, which does not contain the complete matching data for all the joins. So now I can go ahead and run my inner join, left join, right join, because that is really important for my data engineering. This is how we are going to run our data engineering. So now let's try out. First, we'll start with the inner join. Let me correct the code and give it to you. So how do we do the join? So first of all, again, I'm going to create a new data frame, sales filter. The filter one, dot join. Going to join with the customer. If we have a common column name, we can simply give it the name, customer ID. Both the tables contain common column name, customer ID, and the type or the kind inner. So dot join you need to give other data frame, then the list of the column and how you are going to join. So I'm going to do an inner join and print inner join result, and instead of show, let me use display. And I've changed the name, so I'm going to change this before I go to you. So let me run this, and I'm going to give this to you. So what I've done here, now we have learned inner join. What inner join is going to do is only going to give us the matching rows. So where are our matching rows? If you look 59 to 62 and 50 to 60, so only 59 and 60 customer IDs are matching. So if you look here, customer IDs, which we are seeing in this data, you will only be able to see 59 and 60, because we are only going to get the matching rows from both the tables. And what are the matching rows? In this filter data, it is only 59 and 60 is the matching rows. So when you run this command as an inner join, you're only going to get the data which is matching in both the table, which is only the ID 59 and 60 for the customer. See, this time we did not created a data which is missing on either side. We simply went ahead filtered our data and created two tables or two data frames, here in this case of PySpark, which doesn't have complete information. And now we are also able to practice different kind of joins. Why we are practicing all these joins? Because when you do your data transformation, when you try to create your star schema, you will always need these joins. And that is why whenever we are learning something, first thing we are learning is how do we join these tables? How do we filter these tables? How do we group by? These are really important commands for your data transformation. So inner join. So all of you are going to try it out, inner join. You can also paste your screenshots. Meanwhile, you are doing, I'm going to prepare for left join code. Very small changes. Instead of inner, I'm going to put left. Now what happens when I do the left join? The table on the left, in this case, this is the first table, says filter. Please go ahead. Shahid, your question. Please unmute and ask. Right now, we have not saved it. We have not reached to the stage. We are going to create the data frame at the end and going to save it. Right now, it is all inside the Spark memory. If the session goes, it goes. So at the end, we are going to run the Spark. That's why we created Spark data frame, because Spark data frame we have options. Spark dot save. We can save in CSV. We can save in Delta format. Different format we can save. So we are going to learn those saving also. So simply we go to save the Spark data frame. So transform the data frame we are going to save. Right now this is just we are learning, so we don't want to save all of these data frames. We will just save one data frame using the Spark functions, which allow us to save in Delta format. You can also save in file section in CSV format or other format like simple Parquet format also you can use, or you can use other formats like tab delimited or etc. We are going to learn that before the end of today's class, we'll be able to save one data frame there. Now the next thing which I'm going to try is the left join. Again, now those of you are attending continuously, you know why do we do the left join? We want to give the priority to the left table for the joint columns which are the keys is not matching. Those rows should also come. So left join, this time it is sales. Ideally, we do these things on transactional table. Why we do on the transaction table the left join? Where the transaction table itself is on the left. The reason is we cannot lose any transaction. We cannot say I earned 50 rupees when I earned 100 rupees. That is why, because if you remove your transaction by doing inner join, your data will not match. Assuming my dimension was deficient, my dimension doesn't have all the values. In this case, what is dimension? Customer is a dimension. Right now, because we have a data which is clean data only here, we did created some examples. Now, if you see here, we am getting more IDs. Now, what are those additional IDs which I'm going to get? So if I scroll above and I look at it, the sales is from 59 to 62. So 61 and 62 should also be there in now this new example. And whenever you look at 61 and 62 and you scroll on the right hand side, you will see for the rows which contain 61 and 62, I don't have data for the customers. So you will not see data for the customers for the rows 61 and 62 because that data is not present in the customer table. I am doing a left join here. It means the data on the left hand side table for which there is no matching record is also going to come. Now, same way you can do the right join. So today I'm skipping the right join and I'm going to directly try the full outer join. You can understand that, on the right, I'm going to get the records from the customer table for which I will have the empty data. So I think I will already explained you the meaning of right join multiple times. If I would have done to the right join, but you can try out. I will get the data from the customer table, not from the sales table, which is missing IDs. So let me try the full outer join now, trying the keyword full. Same code. I have just changed the join. I've just changed the variable name. Nothing I've done. In fact, I forgot to change the print statement. So it's still printing left, but it is not left. It is actually the full join. And in the full join, you see observation number one, 50 to 58, missing in sales coming here. This will also come in right join for us. But what is the additional come here? Go down, you will also get 61 to 62. And when you scroll for 61 and 62, you will see the entire data, which is blank for the customer, is also coming, which was also coming when we did left join. So missing in the left table, missing in the right table, the join column, those rows are also coming co- along with the rows which are matching rows. So matching plus rows which doesn't have the matching IDs, all are coming in the full outer join. So now you know how to perform all these joins here. Quickly try this out while I'm preparing for anti-join. So what I'm doing is I'm trying to do the left anti. Let's see, do we have a keyword left anti? Okay. So now can somebody explain me, those who have attended all the classes, what is left anti means? We have done this left anti in SQL. We have done left anti in Dataflow Gen 2. Can someone want to highlight what is left anti going to give us? What does anti join means? Something which is present in the left table, not present in the right table. What is the left table? Sales table. So data on the sales table for which I don't have the IDs in the customer. Which are those tables? Which are those IDs? So left data frame, what are there in the left data frame which is missing in the right data frame? Sometimes I use the word table because we keep on working with tables. But when we are talking about PySpark or Pandas, we are talking about data frames here. In the memory, they are available. So you see only data coming from 61 and 62. And the reason for that is 61 and 62 is only available in sales table and not available in the right table, which is customer table. Or do we have a right anti join? Yes. So the so it is basically A minus B. Something which is present in the left table, not in the right table, is going to come. Now there is no right anti join. If you try right anti, you will get an error because there is no right anti join. You have to switch the tables. So anti and left anti. There is only a keyword of anti also. Anti and left anti both work as a left join. So you have to actually switch your tables to work to make sure you have right anti join because there is no right anti. So ultimately you will end up doing the left anti join by switching the tables. So I'm again now these are the records in the customer. The customer not having any sales. This could be a question. How do you find out the customers who is not having any sales? So I'm going to do a left anti join or anti join where customer tables would be in the left, would be on the left, and the sales table would be on the right. And in that manner, when I do the anti join, I will be able to get the records for the customer I have not done any kind of sales. Fine. So now in PySpark also we have learned all these joins, but joins is fine. Filter is also fine. We do analysis, and for analysis we need to group the data, isn't it? Or sometime we may have to even drop some columns, remove some columns. So now I have a problematic table here. The customer table, if you see, it contains state and city. And the geography table also contains state and city. So if I combine these tables, somewhere they're going to create a problem. What I can do is customer, I can drop state and city. So how do I drop the columns? So customer dot drop, now the list of columns, comma separated in single quotes, and then I can get the same table. So I'm overwriting the customer data frame by dropping it the sales, say state and the city column. So how do I drop the column from data frame? I'm not dropping it from actual table right now. It is in memory. When I overwrite this table, that will happen. But right now, there is no table referencing. It's just a data frame. So it's only removed in memory in the data frame, dropping the columns. Now I would like to create a real big data frame by combining all these tables. So remember, when we are going to combine, there are still chances to have duplicates because the ID columns are same. Also, in one of the table, we don't have the same ID column. How do we deal with that? Because till now we have learned the join with the common names. So let's do it step by step. Now I could have used the same data frame name so that I could save little more space or memory. Because if every time you see I'm just changing the name, that's not the ideal way. I should have overwritten the same one. That would have just overwritten on the older name. But just for simplicity, what I'm doing is sales and customer, sales dot join customer. And this is not the sales filter. This is my original sales, 30,000 rows sales joining with my customer, all the customers and all the matching data on customer ID, common column name. Then I take this data frame, which is the new one, customer. Look at this first line. I have customer, sales customer. Then I take the sales customer, join it with geography. Again, city ID is a common column. I'm joining. But when I come to the next, when I take this city customer geography and I try to create the next table, the problem comes in the item ID and the item ID is not saved. How to deal with such cases? So here you are going to see item and then I have join, and this join is not inside the double quotes. Sales dot item ID double equals to item ID dot item ID and the join type is inner. All these joins are inner. Why am I doing inner join with the sales table? Ideally, I should be doing left join, but in this case, I know all my tables have matching data, so I can afford doing inner join. Ideally, all these should have been left join in favor of this table. So this could be the operation I'm doing to populate my surrogate keys, the new keys which I created in my dimension. So today I'm not doing that. So that's why I'm not doing the left join, but I can combine all of them. And finally, I can show this or I can display this, whatever I want. Hash is used for comment. So let me display the combined data. I'm going to comment show and I'm going to enable display. I'm also going to give these things to you. So try this out. We have now created a combined one. Try out the combined one. We have combined all three tables. Now, usually what would be scenario where we are going to get this? When we are going to populate the surrogate keys, when we are going to join our dimension tables, fact table, we populate the surrogate key. That is when we are going to do this kind of stuff. We are going to combine and create a data frame where we'll have surrogate key. In this case, we are not doing that operation. We don't have to populate that. We are just doing for learning purpose. But this is the typical exercise you do to populate your keys which you have created into the tables, dimension tables. You want to populate their keys. You are going to do this operation. Now, if I want to know all the columns in this table, I can do sales all dot columns. Again, I can use print or display sales all dot columns. I can print those and I can see what all columns I have. Basically, after combining what all columns I got. Definitely you need some formulas. You remember we done added the formulas in the past. We did added the formulas. So how do I add the formulas? Now we are going to learn that. So with column is going to help us to add the formulas. So sales all I created, sales all dot with column. After the with column, I give the name of the formula. Then using the call, I can get the column in the expression. This is my expression part. Call quantity multiply by call price. And to execute this, I need a library SQL function where I need call and expression. So expression is something which I'm giving in the second argument, and column is the one which I'm using to get that column. So I'm writing down an expression which Python or PySpark is going to execute in very much similar the SQL fashion is, and I'm getting my formula. Gross is equal to call quantity multiplied by call price. If you would have remember, we have done the same thing in Power Query as well as SQL. Same way I'm calculating COGS as well as discount amount. And every time you now can see I'm overwriting my sales all data frame. Every time I do does an operation, add the with column and using the same one, it means all these columns are going to add to the sales all. And let me run this and provide this information to you. So I'm running it and I'm going to get additional columns in my data frame now, which are formulas. So now we know how to create formulas in PySpark. So you are no more dependent on SQL, or you don't need data flow gen 2 to do those operations. Oh, I have a new column. What I will do, I want to use PySpark. No, you can do pretty much everything in PySpark also. So you can move your transformation to notebooks. And now you know, now we have done more transformation. We have added new columns. We used filters. We're now adding new columns. Try this out. If you have any question, let me know. We'll move to the next operation. Now what happens? We create aggregation. We analyze the data. What we have done on that day, group by, isn't it? We select certain columns, we say group by. Two types of column, group by columns, and those columns which are not group by, we need to aggregate them. How do we do that? Simple way I can tell you, you know SQL. In the starting, I told you one command, spark.sql, write down.sql. You will be able to run. That is spark.sql way you can run your SQL command. You could have run that group by command here. Okay, do try that out. But I'm going to tell you the native PySpark way to do that. So I want to do grouping. How I'm going to do is sales all dot group by. Group by is function. See, very similar to SQL. Use group by there. We have group by there. After that, column names, double quotes, comma separated. I want to group by on city ID. Can we get the output table format? Just give me 1 second. We are going to save that also. .agg. We can save in any format. We are going to save in delta format so that it become table. When we save the file in delta format, it's going to become table. Let's understand that. We are going to quickly do that. Now group by city sales AGG function. Inside the AGG function, we are going to give expression. We have already imported expression in the last one. If you remember, call and expression, we already expression. Inside the expression, sum of gross sales as total gross sales. See, very similar to SQL. Sum of COGS. These columns are already created inside sales all. If you scroll here above and see sales all, you have these column gross, COGS and discount. These we have added just before this command. And then sum of discount as discount amount. All these expression. This is my group new data frame, group city state, and can simply show this. I'm going to run this, and you can run multiple such combinations to get your aggregated data, and that aggregated data again you can analyze using those charts. There are other kind of charts which are also available. I'm also going to share the videos for those so that you can go ahead and play around further with. But let me go ahead and do one thing. We paste this into the chat window. This complete one is not working. Now I'm going to skip quite a few instructions which I've shown in the blog, and we are going to finally go ahead and look at how can we save. So the function which we are going to use to save this file, sales dot write dot format delta dot save table as sales delta. So I'm saving the sales table. You might face, if you want to save the sales all table, it may still contain the duplicate of IDs which we have not removed. So we might have to work that little bit before we go ahead and do that save. So we are going to use the first way to save, sales dot write dot format should be delta. You can use other formats also. Delta is the format which is treated as table, that's why I'm saving it as delta. And save as table, sales delta. I'm giving a name sales delta because I might have already have a table sales, as you can see. And let me run this. Where it is going to save, it is going to save in my default lake house. See, I'm not mentioning where it should save. It is going to save in my default lake house. This is what I think some of you are asking. Saving in the delta format, delta Parquet format means it's going to create it as a table. Then I'm going to show you one more way to save this. Let it run. It's got completed. But how do you going to validate this? You have to go to your this Explorer. You have to refresh your tables, and the sales delta should appear here. See, at the last, you got sales delta. You can further go and query this. Now it is so there is a table. Now this sales table is not going, even if you end this session, the sales delta will remain in your lakehouse. It is now committed to your lakehouse. I'm going to add another piece of the code. Everybody is not able to see my screen. Can someone else confirm? Should I stop sharing and start sharing again? Let me do that. Stop sharing, start sharing again. Okay, I've stopped shared and started sharing again. The last command we have for the run today is I'm now going to save my geography table. Geography.write.format dot the format is delta, mode is overwrite, save, and here I can give the path table slash geography. This is another way I can try it out also. Here I'm not saying save as table, I'm simply using save. Okay, here this is also going to do the same job, but look where I'm saving. I'm saving it under the tables, and under the tables I'm saving it is in delta format. Anything saved as a delta format is going to be a table, and here you should also be able to see now a delta table geography. I'm going to give you the command, and I think be able to see that. Okay, so I think it's taking a little time to appear here. Maybe I'm just not refreshing properly. Let me refresh all the tables. See, it came here. It did not came in the DBO schema. The reason is I have not mentioned the schema, and that is where this problem has happened, because this code is little older code. So let's remove this. Okay, I need to go and do a cleanup. We have to actually provide a schema. So let's try DBO. Dodge STB. Let's try this again. Now it should appear in the DBO schema. Let me give you this one. It came. So remember, when you are using with schema, you do have to provide the schema as a folder. And if you don't provide, you can see the issue which has happened. Now we have to go to the lake house and delete that. It may create little problems. So we have to delete this from our lake house. So give this command /dbo /table name. When you have schemas, if you don't have schema, you can simply give table /auger. So in this manner, you can try out the PySpark command. Today we covered all those. So the basic intention here is you should be able to do data engineering using PySpark or Spark SQL, which is the most powerful. So now we are going to wrap it up for today. Let me see if there is any questions.